Okay, so this time we will use Newton's second law in solving this specific problem. So we have an elevator that is going down. So initially, meron siyang velocity that is downward. So let's label this as VI. And yung initial velocity niya is 10.0 meters per second. Tapos, yung mass ng ating elevator is equal to 800 kilograms. Ganun kabigat yung elevator. So it's going down, and it is actually slowing down until the point na when it reaches the bottom of the floor, or yung ground floor, the velocity is equal to 0 meters per second. So ito yung final velocity niya. Now, the displacement that it took going down is equal to, so we will label this as S. So yung displacement niya is 25.0 meters and direction is downward. So ibig sabihin, started yung motion sa taas, nag-stop siya after 25 meters. Now, since this is an elevator, meron siyang cable that is attached. So what we are asked to find here is what is the tension doon sa cable na yon. Anong tension niya? Okay, first, as we can see here, hindi na at rest yung object or hindi na constant yung velocity ng object. We see a change sa velocity niya from 10 meters per second downward up to 0 when it reach yung ground floor. So, meron tayong acceleration dito. Now, we are not given kung ano yung value ng acceleration na yon, but from this given information na binigay sa atin, we can actually solve for the value of the acceleration A. So, let's try to do that first. Let's solve for the acceleration. So, we can use this kinematic equation here. Vf squared is equal to Vi squared plus 2as. Now, to make our solution simple, let us assign some sign conventions here. So, we will let the direction that is downward, pag substitute natin sa ating equation mamaya, we will assign it with a negative sign. And then, yung upward naman na motion, we will assign it with a positive sign. So, this makes our initial velocity Vi, instead of 10 meters per second, since downward siya, this will be 10.0 meters per second negative. So, negative 10 na siya. Our final velocity, it is still 0 meters per second, but our displacement, since downward din, yung displacement niya, downward yung displacement, we will, again, add a negative sign here, so that is negative 25.0 meters. Okay, so we will use this sign convention. So from our equation, we will now solve for the acceleration doon sa ating object. So we have Vf squared minus Vi squared. So we just transpose itong Vi from the right-hand side ng equation to the left-hand side of the equation. Okay? Tapos we will try to transfer itong 2 at saka itong S doon sa other side. So we are left on one side, we are left with the acceleration, which is equal to Vf squared minus Vi squared divided by 2s. So now what's left is to substitute yung ating values using yung pinili natin na sign convention. Downward is negative, upward is positive. So A will be equal to 0 meter per second squared minus negative 10.0 meter per second. And we will square this. Let's divide everything by 2. Our S is negative 25.0 meters. And so if you use your calculator, you should get an acceleration that is 2.00 meter per second. So ito yung acceleration nung ating elevator. Now, since positive yung value ng acceleration, kasi may pinili tayong sign convention, now this means na yung direction ng ating acceleration is upward. So, if we go back dun sa ating figure, let's try to draw yung acceleration. Ang acceleration ng elevator natin, if it is constant, is equal to 2.00 meter per second squared. So, dapat pala may square yung unit natin kanina. This is meter per second squared. So, this time, meron na tayong acceleration. Let's try to solve yung problem solving the tension dito sa ating object. So, we will use the same approach as we did doon sa Newton's first law. So, our first step is to draw the free body diagram nung ating elevator. So, we will represent our elevator with a simple dot. So, let us draw ano yung forces acting on this elevator. So, it is quite simple. We have yung weight ng ating elevator. And then, we have yung tension nung cable connected to our elevator. Now, we know that the acceleration is upward, and that is 2 meters per second squared. So, it is useful kung nasa second law na tayo, kung nakita natin yung object is accelerating, it is useful to also draw yung arrow representing yung acceleration. So, kahit dito lang natin ilagay sa gilid. So, this is the acceleration. Next, let's choose an axis. So, in this case, yung conventional axis lang ang gagamitin natin. Horizontal will be the x-axis, and vertical is the y-axis. Now, let's look at yung sum of forces along x. So, the sum of forces along x should be equal to the mass ng ating elevator times the x component of the acceleration. However, if you look at yung ating acceleration, it is upwards. So, pataas lang yung direction niya. So, if you get its x component, you actually get 0. Kasi our acceleration is only along the y-axis. So, this means that the sum of forces along x is equal to mass times the x component of our acceleration is 0 or is equal to 0. Which makes sense kasi there are no forces along the x-axis. So, yung value ng sum of forces along x should also be 0. So, actually, wala tayong makukuhang equation for the sum of forces along the x. So, we go to the y-axis. So, the sum of forces along the y-axis, since meron tayong acceleration, we will use Newton's second law, mass times acceleration along the y-axis. Okay? So, let's look at ano yung forces acting on our object along the y-axis. So, we have two. We have tension. Direction ng tension is upwards, so that should be positive. And then we have the weight of our elevator. So, ang direction niya is downwards, so negative yung value ng ating weight. So, we have T minus W. Now, this is equal to mass times the y component ng ating acceleration. So, if we draw another axis, looking at our acceleration, so we'll see na yung acceleration natin is only on the positive y. And ang value ng positive y na acceleration is a. So, actually, yung y component ng ating acceleration is a. Now, kung downward yan, yung acceleration natin, then it will take a negative a na value. But since upward siya, so it will take a positive value. Okay, so yan yung equation natin. Now, we are trying to solve for the tension nung cable connected to our elevator. So, from this equation, we can now actually solve for the tension. That is simply T is equal to MA. We are trying to transfer itong weight to the other side. Negative siya dito. Paglipat niya sa kabila, naging positive na siya. And remember that weight is equal to the mass of the object times the acceleration due to gravity. So, we can write that mg. Now, since meron silang m, both sides, actually, you don't have to do this. You can directly substitute yung values that we have. But for simplicity's sake, you notice na may pareho silang m, so we can factor that out. So, we have m, a plus g. Okay, so that simplifies yung equation na kailangan nating isolve. So, at this point, we simply substitute yung values that we have, yung given values that we have. The mass of the elevator is 800 kilograms. Tapos, we will multiply that to the acceleration. The acceleration of the elevator is 2.00 meter per second squared plus acceleration due to gravity, that is 9.81 meter per second squared. You notice we did not put a negative sign dito kasi we are now dealing with magnitudes. So, G lang ito siya, A lang ito siya. Wala siyang direction na. Na yung component, A sub Y, this is sensitive sa direction. Pero yung A lang, which is the magnitude lang, hindi siya sensitive sa direction. So, always positive lang ang value niyan. Okay? So, hindi natin kailangan lagyan ng negative itong G. So, if we plug this in to our calculator, we should get, rounding off to 3 significant figures, we should get 9,450 and the unit is in newtons. So, yan yung tension force doon sa ating cable connected doon sa elevator. Okay? So, that's how we apply Newton's second law in solving problems in mechanics. So, a few notes. Ano yung mga nagbago dito? It is useful to draw, along with our free body diagram, yung direction ng ating acceleration. Yeah, this will be a guide later in forming yung equation natin. Ano yung x component ng acceleration, ano yung y component ng acceleration. Tapos, the other thing that changed is instead of the sum of forces along the x being 0 and along the y being 0, meron na siyang value ngayon. And the value is mass times the x component of the acceleration for sum of forces along x, and then the y component ng acceleration for sum of forces along y. So, yun lang. Tapos, you still substitute all of your values, tapos you can create your own equations that you can use in solving yung problem. So, that's how we use Newton's second law in solving a problem in mechanics.